is going to put the answers to the warm-up up for us.
Personally, I would have gone like this color, but this is.
Why did you give me 7? I don't know where
They're sold out.
Those are still cool.
These are cool spikes because they have an air bubble at the sandwich between like the spike and the fishes. So it's like when you like sprint, it's like kind of bouncy.
The extra.
Yeah.
What events are you doing?
100 meter and 200 meter. And then maybe 4x4.
I don't know. And I was just like, I kind of had this, but I couldn't figure out.
I know. Okay, the ones that do like the 3,000.
I'm not a long distance person.
Yeah, I like the word. I actually don't like the
Until I kept hearing all this.
okay.
Like quad.
Yeah.
You guys should be paying attention to Jillian.
I pulled out my stuff. Portland State.
I'll fix it.
That's sad. Sorry. It's okay. That's not. But,
That part is good.
I wanted more money.
That's a long form.
What's that long for?
The FAFSA.
I have to do my CSS profile, and I've been putting it off.
I do it all myself.
Maybe it's changed since I was in school.
I don't know. You just like
I have too many legal parents. Like, I must have known all the years.
Yeah.
I don't want to
You
deal
had
with
to
that,
actually
honestly.
mail in taxes.
Oh God.
When I was in high school.
Dude, I saw like the tax form, like the fiscal
You
tax
had to
form.
print it. It was pretty darn thick, and then you had to mail it in.
We were supposed to go.
I'm so thankful for like TurboTax and everything, because like I
That's
could
what
never
I
do
use
that.
now, and
Yeah,
I do it
so
all electronically, but back then,
I don't remember.
Next year, Billy.
I could never.
I am starting to really feel old.
Because we make fun of you too much. Oh, can I just borrow a
I think I'm out of time.
Oh my gosh.
I'm sorry, I think I left it. Wait, just kidding, it's right here. I found it.
Bruh.
This is what it is, right? So I just write that.
You reject the no.
Thank you, ma'am. All right. Parameter. We're interested in the true proportion of free throws that Madeline has made. H null is her claim that she's a 70% free throw shooter. We think she's not that good. Sorry, Madeline. Then if you calculate your p-value, so remember when you draw your picture, you assume the null is true, so it's centered at 0.7, and then Jillian showed her work for finding the standard deviation. She labeled her standard deviations above and below. Our p-hat, Maddie made 25 out of 50, so our p-hat is 0.5 right here. So then for normal CDF, really small number, the upper bound is 0.5, mean 0.7, standard deviation 0.065, which gives you a p-value of 0.001. And since that p-value is less than alpha, our decision would be to reject Maddie's claim that she's a 70% free throw shooter. I was nice, I didn't make her write the full conclusion, the whole novel, just the key little phrase there. All right, so like I said, today has a lot of information. We're going to talk about type 1 and type 2 errors, and we're going to talk about the power of our tests. So, maybe Maddie is right. Is there a possibility that we might have made the wrong decision in the warm-up? Could Maddie actually be a 70% free throw shooter? Maddie?
Tell us.
No?
Tell us, Maddie.
No?
No.
All right, so you might want to make a little note to yourself. In the warm-up, we rejected H null. I mean, I suppose you could flip back and forth, but that's never fun. So, okay, Maddie, this is going to sound horrible. This is like Cheyenne. I started to write Maddie, and I've got about 5 Maddies between all my classes, and you're a Y, right? But I wasn't positive, so I didn't want to put Maddie, so I put Madeline, because I knew how to spell that one. You do 2 Ds too, right? Suddenly this D appears out of nowhere, because you only have 1 D in Madeline.
Exactly.
And then it comes out of nowhere, and now we have Maddie. I don't get that part. All right. So that's why I used your full name on the warm-up, because I was pretty positive you were a Maddie with a Y, but I didn't want to put it and then be wrong. Anyways, so is there a possibility that we made the wrong decision? So right now, we chose to reject H null, but is there a possibility that H null could be true? Hey, it's Calvin. So, excuse me, H null could possibly be true. It's really unlikely that H null is true based on the p-value we got, but there is a possibility. It's just a really highly unlikely possibility. And that's where type 1 and type 2 errors come into the picture. Sometimes we're going to make the wrong decision. Imagine that in math, you make the wrong decision. So our picture is kind of like a, what are those squares they teach you in? Thank you, Punnett.
Oh, reading Punnett squares?
Maddie can read my brain.
Reading Punnett squares and not.
Yes.
Oh.
And we'll look at them in chapter 11 too.
Oh.
Anybody in AP Bio or have taken AP Bio?
It's like regular.
Chi-square. That's chapter 11 in statistics. It's actually one of my favorite units to teach. You'll be really mad at Almanza because if I remember correctly, he has you do all the math by hand. The calculator does it for you. Yeah.
Wow.
All right. So across the top is what I call the truth. And going down the side, that is the decision that we end up making. So, when we are working with hypotheses, there are 2 options for the truth. H null is true, or HA is true. And then our decision, there are 2 decisions. We can reject H null or we can fail to reject H null. Do I need to zoom in, Molly? Maybe you should be in your assigned seat, Molly.
Is that also a fire? This is better for
Wait, are they?
Actually,
Fail to reject.
what's your question, Anna?
Does it say fail to reject H null and false null?
This one says failed to reject H null. This says reject H null. So, if H null is true, and I failed to reject it, I've done a good job. If the alternative is true, and I reject the null hypothesis, I also did a good job. Thank you. However, if H null is true and I reject H null, that's a type 1 error. And yes, they do use Roman numerals.
Nice.
If the alternative is true, and I fail to reject H null, that's a type 2 error. So, just to kind of put it into words instead of a picture only, type 1 error is when H null is true. And I reject H null. Or in other words, I accept the alternative as true. So I made the wrong decision. Type 2 is when the alternative is true and I fail to reject H null. Or in a more positive wording, I accept H null is true. The power of our test is excuse me, the ability of the test to correctly detect the alternative. So in the words of our picture above, that would be when the alternative is true and I correctly reject H null. And that is this one in the top right. H null is true and HA is true and I reject H null.
So whenever he says power, you just assume
Mm-hmm. That's the definition of power. The alternative is true, and we correctly rejected the null. Anna?
Like when you do like we asked about power.
We'll look at that later in the notes. Any other questions? Can I move it up? So first thing, we're going to look at type 1, type 2. So Childers runs an auto parts store. Every Monday, a truck delivers him a large shipment of brake rotors. He will only accept the shipment if less than or equal to 9% of the rotors are rusty. If there are more than 9% that are rusty, he sends the shipment back to the manufacturer. He does not have time to investigate the whole shipment, so he takes a sample of 100 rotors, and he uses the following hypotheses. Null hypothesis is that the proportion of brake rotors that are rusty is 9% or 0.09. The alternative is that the proportion that are rusty is greater than 9%. So describe a type 1 error and what's the consequence of a type 1 error. So a type 1 error is when H null is true and we reject H null. So in terms of our null hypothesis here, if H null is true, 9% of the rotors are rusty. Which for Childers means he'll accept the shipment. He thinks it's a good shipment. The other part of the type 1 error is we reject the null, which means that we accept the alternative to be true. So we would think that greater than 9% are rusty. Or that really it's a bad shipment of rotors. So then we have to think about the consequences here. So it really is a good shipment. There are less than or equal to 9% that are rusty. But we think the alternative, that more than 9% are rusty, so it's a bad shipment. So what are the consequences of this error?
He returns it.
He returns it, right? So he sends back a good shipment, which means what? Does he have parts to put on his shelves?
No.
So he's low in parts. What else would happen? He could lose money. What about the manufacturer? If I was a manufacturer and I sent out a good shipment and somebody sent it back and said that was a bad shipment, I'd be a little angry. Like, what are you talking about, buddy?
You have to pay shipping.
He may have to, who knows? They may say if you send back the parts that you have to pay for the shipping. I think the biggest thing is the manufacturer. First of all, you're going to lose money, but the manufacturer is probably going to be a little angry. Any questions on that part so far? So then type 2 error. So a type 2 error is when the alternative is true and we failed to reject the null. So if the alternative is true, that means more than 9% are rusty. So in other words, it's a bad shipment. And we failed to reject H null, which means we accept H null. So we think that there's 9% that are rusty. So we keep it. So we assume it's a good shipment. And what would be the consequences of a bad shipment and keeping it because we think it's really a good shipment? Rusty parts, which would result in what?
Loss of money on customers.
Customers are probably going to be angry when they buy bad parts, rusty parts. I'll be honest. I don't know. I mean, brakes are important, but I don't know what a rusty rotor really means. Does it mean your brakes don't work? So, I mean, it could result in accidents. Who knows? I don't. You would think I would know that with this example, but I don't. Angry customers. Because you give them bad parts. Somebody said lose money. Bad parts. Probably lose customers if you're selling bad parts. They wouldn't come back. Did I miss any that you guys said? Any others you want to add? Alright, so which type of error is more serious in this case? And can you justify it for me? Anybody? Which one's? Hannah?
Type 2.
Why do you say type 2?
Because there's more risk of injury.
I would agree with you. Type 2, because bad parts could result in an accident. Maybe, possibly. Like I said, I really don't know what a brake rotor router does. Now, when you're asked which type of error is more serious, a lot of times it is going to be an opinion, or it's going to be completely obvious which one is worse. But I know that math, we're pretty used to it being black and white. Sometimes choosing which error is worse is just a matter of opinion. The biggest part is that you can justify why you think it's worse. Questions? All right, you guys are going to try one. A company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. The company selects an SRS of 15 new batteries and uses them continuously until they are completely drained. A significance test is performed using the hypotheses. Null hypothesis, the average amount of time that the battery lasts is 30 hours. The alternative, average amount of time the battery lasts greater than 30 hours. Mu is the true mean lifetime of the new deluxe AAA batteries. The resulting p-value is 0.0276. Describe a type 1 error, describe a type 2 error, and then tell me which one you think is more serious in this situation. Out. You were asleep. It's like when I fall asleep on the couch at night and my daughter wakes me up and she goes, "Mom, you can't fall asleep yet." And I go, "I was asleep and I was just resting my eyes."
That's what I said too. That's what I said.
I wasn't asleep. I just had my eyes shut and resting. You fall asleep in desks. Put me on a couch and I'm out.
Or
In the car?
yeah.
While driving.
While driving.
No,
Oh.
please no.
Does this say it lasts more than 30 hours? Or less? It's more, right?
For the alternative, more.
Okay.
More.
Advertising. Alright, go. Well, do you think they'll get sued for that?
So they will only produce the batteries if they actually last longer. So if H0 is true, they only last 30 hours. But we reject the null and think they last longer than 30 hours. Here, they last longer than 30 hours, but we fail to reject the null, so we think they really only last 30. Which one is worse in this situation? Okay. Did that help clarify a little? that one sentence is really key. That they're only going to produce them if they actually last longer. Well, it doesn't actually say that. It says because they're more expensive to produce, they want to be convinced they really last longer. The null, or excuse me, the alternative last one 30. So if we accept the null, they last
Less than
30.
30. Oh,
Or just 30.
Not longer.
Wait.
Yeah, it's kind of confusing.
May I see?
What do you want to see? Okay, that's not bad. That's not bad at all. Good job. What's the name? Wow, that one's pretty good. That's not bad at all. I'm taking
I
that.
like really out.
Probably right down to 86, but I mean, if I do got everything else, it's still
I'm like,
figure it to write it like that.
Here it is. So they last longer than 30 hours, but we think that they last 30. They last longer than that. But we think they really just last 30. Here the truth is they last 30, but they last more than 30.
What?
So, I mean, we're really just switching
I'm
up,
part of the
but they
team,
use
yes. But I was surprised that
one is worse than the other.
I'm taking one of the vocab tests, and I guess I was wrong, and I wasn't sure is it. And so I had like a C.
Was there batteries before they actually lost? Why would the company throw out batteries?
That's bad for the environment. They should be.
Wait, what do you think the consequences of the
No, they're only gonna.
I said mix out and then go products and then we yeah, so like you miss that.
So why would they make batteries just as wrong?
What are you even talking about, Mama?
I did stuff. I guess I went to like actually. My sister wanted to go like this. I went to Target and then I was like, oh, I'm gonna do all this homework. I got home. I didn't make
Why do you
use it.
Sort of. I was just dreaming about things.
Why do you think
Never became real.
Yeah, and Saturday I had like a weekend.
That basically just
Yeah, oh my god, my planet like broke. Wow, like literally right before I went to like for my solo. So my solo went like very really kind of great. So I like made a place for my solo, got a place for my foot.
what are the
Saxophone choir. So we're going to state for my saxophone as well. And we might go to state for my duet, but yeah, it's silly. But I have a concert tonight, so I'm like trying to like go test a bunch of my clarinets and see if I can play any of them.
Probably it's okay on
Well, yeah, so basically, wait, like the whole entire thing?
the whole entire thing.
Oh my gosh.
You got this.
So kind of almost like as long as the keys work, it doesn't really matter which one I have.
How do you even fit all your thoughts?
So yeah, I had to like put random pieces of random clarinet together on mine until it felt like so it was like completely broken.
You got me there.
So that was like a stressful day, but Sunday I did that.
I believe really like.
That's all I do. All I do.
She said she graded us. I haven't seen it posted.
That's a pretty good name.
Still not. Still not.
I think she's a liar.
39.
A liar.
So,
I love how we
because that one was only in the 50.
fall over.
Yeah. I was like, that's
Wait, so for both type 1 or 2 errors,
because that's it.
I don't think
It was very good.
I don't.
I was gonna ask.
There's nothing for me to say about this model.
On my notes, it says real stuff.
Like how yourself like
I'm not stressed about it.
There's
The
reason it was written. Yeah, it's
I wish it
like-
was
Like,
Eric is supposed to sit there.
and I knew she had told me that there's not the one that
Yeah.
she said, yeah, I can but
No, it's just the first.
Yeah, you
It's
said that was
not
not
like, it's just, it's a good person. Yeah, she's not saying anything about society. She doesn't even part of society. She lives outside civilization. She lives in a cabin in like the edge of the woods.
Yeah.
So,
Because I wonder how many tests we're going to have.
she was a pilot for 90% of her life. It made me so mad that I had to write BS about the story that I knew was like shows she very openly about societal issues. No, she wasn't. She was hard.
I mean, you like learning about the drugs. Don't you love all the
What?
all the weird books?
They make us read books that are like, okay, why? What is the relevance of that? Why do I need to know
You
about
guys
relevance?
question why you have to learn things in math.
In math?
I was
In like
so
calculus, yeah, not like
It
statistics.
actually did good though.
I can accept statistics because it's like I like to kind of have used this stuff outside of class.
Oh, by the way, you know what I found out today?
Makes more
Just like
sense.
this.
Yeah. It's also just more logical, I feel. It's like calculus is just a bunch of formulas.
I would agree with that. I will say I did like math.
Yeah, I liked it.
What?
It was also
Yeah,
like,
that's I figured it
I
out.
went through all of it and I was like, is there
Yeah.
anything? I mean, I
Well,
passed
if
all
I
the
keep up
tests
to you,
with
that's
an
what
A,
you say.
but what can I use here?
That makes me so mad.
Yeah.
He's
He
out.
gave me like a tire
That's why I'm
the
saying,
other day, and I was like,
They were really big. They were. I was like, I did barely
It's
any of the
for
whole.
in regular with Miss Chair.
honors with checkers.
Well, she gave you the whole unit.
No, I had it
Well,
on.
there's a difference between D and D.
And
They're
it
just
was really
English
hard.
and
Yeah, you have to do all. You either had to print out this like 40-page packet or do it online. And I was like,
Don't do that.
how about
Just
I
don't.
just
You're
don't
better
do
than
it?
that.
And so I did it. And I still got an A in the class.
Good job, Nate. All right. Type 1 error. Null is true, so the batteries last 30 hours. But we reject the null and accept the alternative, so we think they last more than 30. So some consequences are you have angry customers because you tell them they're going to last more than 30 hours, but they don't. You lose money. And I already said the last one that she put down. Type 2, the alternative is true, so they last more than 30 hours. But we failed to reject the null, so we think they only last 30 hours. So the producer loses money. You think batteries last 30 hours, but they last longer. Which one is worse, type 1 or type 2? She said type 1 because customers don't get what they are expecting and they lose money. Sorry, my brain. No. I know some of you said type 2. Did anybody say type 2 and want to share? my biggest thought with type 1, so with type 1, the batteries really only last 30 hours, but we think they last more than 30. So the company is going to produce the more expensive ones, and so they're actually losing money. So I would, maybe if you want to add that, the company loses money because they're producing more expensive ones that pretty much are the same as their regular ones. Nate?
Yeah, I wrote in my answer that I think type 2 would incur more immediate losses because you have to scrap all of R&D, and that's just a whole bunch of costs right there. But that type 1 would incur more losses in the long run.
I like how you worded that you have to scrap R&D right away. I suppose you would, but yeah.
I mean, that's
Yeah.
honestly the state.
Yeah, I mean, they just did a whole study on it, so to find out that it was exactly the same. All right, down below. So, type 1 error. We're going to look at how to find the probability of a type 1 error. So we're going to go back to Maddie and her 70% free throw shooting. And we're going to figure out what values for p hat leads us to reject H null. What values lead us to fail to reject H null. And we're going to use an alpha level of 0.05. So remember, type 1 error is when H null is true and we reject H null. So you might want to just remind yourself H null is true and we reject H null. Probability, like I said, we're going to find the probability of a type 1 error. Hopefully that word makes you think that we're going to a normal distribution. So we're going to look at our normal curve. We're going back to the 70% free throw example. And H null is true. That is the key part here because it's a type 1 error. And that means H null is true, but we reject it. So if H null is true, that means we have 0.7 at the center. And then Jillian found our standard deviation for us in the warm-up. It was 0.065. I'm going to be lazy. I'm not going to label all my standard deviations. It's not super important in this picture in the big scheme of things, so I'm not going to draw them in. So we know that alpha is 0.05. It tells us right here that we're working with 0.05 for our alpha level. And we want to figure out what values of p hat lead us to reject H null and what values of p hat fail to reject H null. So when do we reject H null? I think somebody said it. But when it's less than alpha. I'm getting old. Remember, I used to have to mail in my tax returns. So we would reject H null when our p-value is less than alpha. So let's make a note up here. We reject H null when the p-value is less than alpha. And we fail to reject H null when the p-value is greater than or equal to alpha. So probability really is what? When we find the probability, what are we looking at? I'm not looking for an actual number here in the picture. The probability is found where? Under the curve? Yeah. It's the area under the curve. So if we want a p-value that's less than alpha or greater than or equal to alpha, we're going to look at 0.05. And p-values really are our probability. So we want to find when our p-hat gives us a probability or a p-value less than 0.05 and when it gives us one that's greater than or equal to 0.05. And remember, back here in the warm-up, the alternative was that Maddie was less than a 70% free throw shooter. So I'm looking for 5% or 0.05 on the left. So if we're in this area, our probability's down here, we're going to be in the rejecting H null area because we're going to end up with a p-value less than 0.05. And then if we're to the right of that, we're going to fail to reject H null because we're going to end up with a probability bigger than 0.05. So how do I find the p-hat value right here at that pink line? You guys do know how to do it, by the way. It's just if you can make the connection. How would we find that p-hat right there? We know the area under the curve. What's the calculator function used?
Inverse norm.
Inverse norms. So we're going to work with inverse norm. Thanks, Hayden. Way to not zone out at that moment for me. Thank you. And remember, inverse norm is your area, so 0.05. And then so far we've used inverse norm to find our z-scores or our z-stars. So we left the mean as 0 and the standard deviation is 1. But I want the p-hat value right here, given the mean is 0.7 and my standard deviation is 0.065. So that is what I'm going to put for my mean and my standard deviation. And when we put that in there, what do we get? Did you say something, Anna?
No, well, I responded to your question, but that's what I said.
Thanks, Anna. We get 0.593. So right here, our p hat is 0.593. So if we get a p hat that is less than 0.593, that means that we're going to be to the left of that pink line, and we're in the reject H null area. If we get a p hat that is greater than or equal to 0.593, that puts us at the pink line or to the right of it, so our p-value is 0.05 or bigger. So we would fail to reject H null. So, the probability that we make a type 1 error, remember type 1 is H null is true, and we reject it. This picture is drawn assuming the null is true. We reject it when we're over in this pink area, and that pink area has 0.05. So the probability of a type 1 error is 0.05. It's just alpha.
It's just mind blown.
Well, if I just said it's alpha, you guys wouldn't believe me, would you?
Yes.
It's like one of those things, you know. If I just said it, you guys would be like, huh, why? But now that I did all that, and I go, well, I didn't even say it. Hannah goes, so it's just alpha. You guys are like, that makes sense. Why couldn't you just say that to begin
Well, I
with?
still don't really understand why, though.
No.
Elaborate more. Don't.
Yeah, you understand it.
You can bet there'll be a multiple choice question about type 1 errors, their probabilities, what it's equal to on your test. It's just equal to alpha.
So that means if alpha changes and it just equals that.
Yeah.
What?
Because in some problems alpha is not going to come from that.
Right. Sometimes alpha changes. So
It's always been alpha.
if your alpha is smaller or bigger, it's still equal to whatever alpha is. All right. Now we're going to look at another picture.
That's the standard deviation.
Thank you, Anna. All right. So this time we're going to use picture to look at the power of the test. So our alternative from the warm-up, remember this all goes back to Madeline and her saying she's a 70% free throw shooter. The alternative is that she's less than a 70% free throw shooter. Now I'm going to give you a specific alternative. And that specific alternative is that P equals 0.5. And we're going to assume the alternative is true. What is the probability that we make the right decision? And remember, that's the definition of power. The alternative is true, and we correctly choose the alternative. So we're going to draw our normal curve. Calvin's having fun over there. So we're looking at power. Power, by definition, is that the alternative is true. So when I draw this picture, I'm going to draw it based on the alternative being true. which means that my alternative, that P equals 0.5, is going to be at the center. I'm going to do a little side work to show the standard deviation. So this is for this one. So remember, our standard deviation comes from the square root of P times 1 minus P divided by N. Well, we're looking at P being 0.5. And 1 minus 0.5 is 0.5. So really on top I have 0.5 times itself. And from the warm-up, Maddie took 50 free throws. So we're going to figure out what that is really quick. 0.5 times 0.5 is 0.25. And then I'm going to divide by 50 and square root. So I get 0.071 if I round. 0.071. So then here I'm going to put 0.071. Everybody good with that part? Okay. So now the question is, HA is true, so my picture is based on the alternative being true. What is the probability we make the right decision? Meaning that we reject H null. Now, this is also part of why I did the picture above, because if the alternative is true, and we reject H null, we need to know the p hat value where we reject H null. And we would reject H null when p hat is less than 0.593. Without that picture, I wouldn't have anywhere to mark on here. So 0.593, so 0.5 is at the center, so I'd say it's somewhere over here. I'm not drawing it perfectly to scale, but it's somewhere over here. That'd be a p hat of 0.593. If we get a p hat less than 0.593, we reject the null. So everything to the left means I'm going to reject the null hypothesis. And that's what we want, right? If HA is true, we really want to reject the null hypothesis. Anything to the right with a p-value greater than or equal to 0.593, we would fail to reject H null. And if the alternative is true and we fail to reject H null, what is that really? A type 2 error. So anything to the right is a type 2 error. So we can find the probability that we're going to make the right decision, or we can find the power of our test. Because if HA is true, and I reject H null, that's the power. Well, I can find the area under the curve for when I reject the null, or I can find the power of my test. So this time, I don't have the area, so it's just a normal CDF. And I want to find the area shaded in green. So my lower bound's a really small number. My upper bound is 0.593. the mean 0.5, standard deviation 0.071. And when we put that in the calculator, what do we get? 90.
0.9048.
0.9048. So about 90.48% of the time, I'm going to correctly choose the alternative. And I guess I shouldn't say choose. The textbook, and if you are taking the AP exam, they use the word detect. I don't like the word detect, but we would correctly detect the alternative about 90.48% of the time. Nate?
So for this, would you be able to say there's a 90.48% chance to correctly detect it?
Sure. Yeah. Now, power, they have a formula for it. Seems kind of silly to me, the way they define it, but this is how they define power. We found the power of our test, but they define it using the complement rule, and they say that the power of the test comes from 1 minus the probability of a type 2, which is what our picture shows. Over here on the right, the alternative is true and we failed to reject the null. That's a type 2 error. So power is defined as 1 minus the probability of that, which you could do. Just to me, it's an extra step. We could find the area over here. Normal CDF, lower bound is 0.593, upper bound big number, mean 0.5, standard deviation, and then you would subtract from 1. I personally find it easier to do it in one step and just find the area on the left side. But if you're asked a question about the formula of power, it is defined as 1 minus the probability of type 2. So just keep that in mind. It's the same thing we just did. I just did it in less steps. But that is, like, if you look up power in your textbook, that's how they define it. Questions? No. All right. I was on this example, I was just going to show you the same thing with the statistical applet, but I think I'm going to skip that, and I'm going to talk about how we improve power. So if we want to increase the power of our test, what do you guys think we should do to our sample size? Increase it. The answer is always increase your sample size. No harm can ever come from increasing sample size. What do you think you should do to your alpha level if you want to increase the power?
Increase it.
Increase it. Now this one is a little odd, but what if we changed our alternative value? Should we change the alternative to be further away from the null or closer to the null? Further. You want to make it further away. questions? No? All right, I think most of you heard me say at the beginning of class, I'm taking one of my kids to the doctor at lunch. So,
Have fun.
yeah.